Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations. So let's get going. Problem. Solve dq plus 1 into y equals to sin 3x minus cos square x by 2 plus cos 2x. Solution. Firstly, let's find order and degree of the given differential equation. Identify the highest derivative here. D cube is the highest derivative, so our order will be 3. And the highest power of the highest derivative is our degree. Degree is 1. Or just write the given differential equation as d cube y plus 1 into y equals to sin 3x minus cos square x by 2 plus cos 2x. We know that d is a differential operator, then d square will be d square by dx square, and d cube is d cube by dx cube. Now we can write d cube y as d cube y by dx cube plus y equals to sin 3x minus cos square x by 2 plus cos 2x. Here d cube y by dx cube is the highest derivative, so our order will be 3. And highest power of the highest derivative is our degree. Degree is 1. Right? Now coming to the problem. So we are given a differential equation. This is an operator form. Given differential equation. D cube plus 1 into y equals to sin 3x minus cos square x by 2 plus cos 2x, which is an operator form. F of d into y equals to q, where f of d equals to dq plus 1 and q equals to sin 3x minus cos square x by 2 plus cos 2x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function. We will find complementary function using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Okay. By taking RHS to 0, we'll get f of d into y equals to 0, which is a homogeneous equation to the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. So firstly, let's find complementary function using the roots of the auxiliary equation of homogeneous equation of the given non-homogeneous equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we are having f of d equals to d cube plus 1. So let's replace differential operator by m, so that we'll get f of m equals to m cube plus 1. Then m cube plus 1 equals to 0. Right? Now we can find roots to this equation using synthetic division method. So here we are having polynomial. I'm just talking about the LHS part. M cube plus 1, right? Consider M cube plus 1. Let's place the equations of m cube, m square, m power 1 and m power 0. 1. Quotient of m power 0. Quotient of m power 1 is 0. Quotient of m square is 0. And quotient of m cube is 1. Now, let's see which m satisfies this polynomial. If you take 1, you'll get 1 plus 1, which is 2. So you don't get 0, right? It's not equals to 0. If you take m equals to minus 1, we'll get minus 1 whole cube is minus 1 plus 1, which is equals to 0. So m equals to minus 1 satisfies this polynomial. Take minus 1, 1s are 1. Okay, 1 plus 0, 1. Minus 1 into 1 is minus 1. 0 plus minus 1 is minus 1. Minus 1 into minus 1 plus 1. 0 plus 1, 1. Minus 1 into 1 is minus 1 plus 1 minus 1 is 0. Again, this gives another polynomial. Right? We can write this polynomial as product of, write later. So from these three, we'll get another polynomial. M square minus m plus 1. Now we have to see which m satisfies this polynomial. Okay. Or let's use quartic formula to find roots. I'll show you what happens if we use 1 minus 1, 2 minus 2. Okay. 1 square. If you take m equals to 1, you'll get 1 minus 1 plus 1 is equals to 1, non-zero. If you take m equals to minus 1, again you'll get minus 1 whole square is 1 plus 1 plus 1, 3, non-zero. Likewise, if you take 2, you'll get 2 square is 4 minus 2 plus 1, which is equals to 4 plus 1, 5, minus 2 is 3, non-zero. Likewise, no m satisfies this polynomial. So what we'll do, we'll just use quartic formula to find the roots. Okay, fine. So from m equals to minus 1, we'll get one factor. We'll get just m plus 1 equals to 0. So here m plus 1 is one factor. We can write m cube plus 1 as m plus 1 into, that is product of m plus 1 into the polynomial obtained from these three numbers, that is m square minus m plus 1. Right? Now we can write this equation as m plus 1 into m square minus m plus 1 equals to 0. Now equate each factor to 0 to find roots. Okay, m plus 1 equals to 0 and m square minus m plus 1 equals to 0. From m plus 1 equals to 0, we'll get m equals to minus 1. From this equation, just compare this equation with quartic equation am square plus bm plus c equals to 0. Then for comparing these two equations, we'll get a equals to 1, b equals to minus 1, c equals to 1. We can use quartic formula. M equals to minus b plus or minus square root of b square minus 4ac by 2a to find roots to this equation. Okay, then for b equals to minus 1, minus of minus 1 plus or minus square root of b minus 1 whole square minus 4 into a. A is 1 and c is 1, right? We'll get 1 into 1 by 2 into 1. You'll get 1 plus or minus square root of minus 1 whole square is 1 minus 4 into 1 is 4 by 2, which is equals to 1 plus or minus square root of 1 minus 4 is minus 3 by 2. Again, you can write minus 3 as some minus 1 into 3 by 2. Then we'll have m equals to 1 plus or minus. Split square root of minus 1 into minus 3 as square root of minus 1 into square root of 3 by 2. Since we know that square root of minus 1 is I, right? So we can replace square root of minus 1 by I. Then we'll get 1 plus or minus I root 3 by 2, right? Which is equals to 1 by 2 plus or minus I into root 3 by 2. So the roots obtained from the second equation is 1 by 2 plus or minus I root 3 by 2. Complex conjugate roots, right? This is real and distinct, and these are complex conjugates. Then m equals to minus 1 and 1 by 2 plus or minus I into root 3 by 2 are the roots to this equation. Therefore, m equals to minus 1 and 1 by 2 plus or minus I root 3 by 2 are the roots of our auxiliary equation. Which are real and a pair of complex conjugates. Complex conjugate, right? Which means one real root or real and distinct, whatever, and a pair of complex conjugate, right? We know that if we have one real root, then yc will be one constant into e power that real root into x. If we have some complex conjugate roots, if a plus ib is a complex number, its conjugate will be a minus ib. If a minus ib is a complex number, then its conjugate will be a plus ib, right? So we are having a plus or minus ib, which is called complex conjugate, a pair of complex conjugate roots. If we have a pair of complex conjugate roots, then our yc will be e power real part into x into one constant into cos bx plus the other constant into sin bx. So let's write complementary function to our problem. Complementary function yc equals to, for m equals to minus 1, you'll get one constant into e power minus 1 into x plus, now we'll write for the complex conjugates, e power 1 by 2 into x into one constant. Already we have used c1, so we'll take c2 here. Cos for b equals to root 3 by 2 into x plus, here we are having c1 c2, so we'll take another constant c3 sine root 3 by 2 into x, right? Therefore yc equals to c1 e power minus x plus e power x by 2 into c2 cos x root 3 by 2 plus c3 sine x root 3 by 2. Now let's find particular integral. We'll find particular integral using 1 by f of t into q is equals to 1 by, we have f of t dq plus 1 and q is sin 3x minus cos square x by 2 plus cos 2x. We know that cos 2 theta equals to 2 cos square theta minus 1 or 2 cos square theta minus 1 equals to cos 2 theta, right? Now, take this minus 1 to RHS, then you'll have 2 cos square theta equals to 1 plus cos 2 theta. Now take this 2 to RHS, you'll get cos square theta equals to 1 by 2 into 1 plus cos 2 theta, right? Now, replace theta by x by 2, then we'll get cos square x by 2 equals to 1 by 2 into 1 plus cos 2 into x by 2, right? 2 gets cancelled and you'll get 1 by 2 into 1 plus cos x. Then we'll get cos square x by 2 equals to 1 by 2 into 1 plus cos x. Since cos square x by 2 equals to 1 by 2 into 1 plus cos x, we can replace cos square x by 2 by 1 by 2 into 1 plus cos x. Then our yp becomes 1 by dq plus 1 into sin 3x minus 1 by 2 into 1 plus cos x plus cos 2x. You can write this as yp equals to 1 by dq plus 1 into sin 3x minus 1 by 2 into 1 is minus 1 by 2, minus into plus minus 1 by 2 into cos x plus cos 2x. Now this becomes 1 by f of t into sin 3x minus 1 by f of d into a constant minus 1 by f of d into constant into cos x plus 1 by f of d into cos 2x. Right? Now you can find each term separately. See here you're having 1 by f of d into some constant, so we can write it as minus 1 by 2 into 1 by f of d into e power 0x. Okay, we'll write in 1 by f of d into e power ax form since we got a constant. And we don't have any function in polynomial like x square, x cube or like that. Okay, so we'll take e power 0x minus one constant or constant into 1 by f of d into cos x plus 1 by f of d into cos 2x. You can name first term as yp1 and second term as yp2 and third term as yp3 and last term as yp4, and find yp1, yp2, yp3, yp4 separately. So firstly we'll find yp1, 1 by f of d into sine 3x. This is of 1 by f of d into sine ax form. Then for a equals to 3, we'll find d square, which is given by minus a square equals to minus 3 square equals to minus 9. See, denominator must be non-zero. Now, take denominator. We can write d cube as d square into d, right? Now, replace d square by minus 9 and see what you'll get. You'll get 1 minus 9d, which is non-zero, right? So, we can replace d square in the denominator. Just replace d square by minus 9 in the denominator. Firstly, write d cube by or d cube as d square into d plus 1 into sine 3x. Now, replace d square by minus 9, which is equals to 1 by minus 9 into d plus 1 into sine 3x this becomes 1 by minus 9 into d is minus 9d plus 1 into sine 3x, which is equals to 1 by 1 minus 9d into sine 3x. See, in the denominator we are having 1 minus 9d, right? So if you replace this minus by plus, you'll get 1 plus 9d. So let's multiply and divide with 1 plus 9d to this fraction. Then we'll get 1 by 1 minus 9d into 1 plus 9d by 1 plus 9d into sine 3x. This becomes 1 into 1 plus 9d is 1 plus 9d by 1 plus 9d into 1 minus 9d into sine 3x. This becomes 1 plus 9d by, in the denominator we are having 1 plus 9d into 1 minus 9d, which is of a plus b into a minus b form, right? You can write it as a square minus b square, 1 square minus 9d whole square into sine 3x. We'll get 1 plus 9d by 1 square is 1 minus 9 square, 81 into d square into sine 3x. See, again d square appears in the denominator. So let's see what happens if we replace d square by minus 9 in the denominator. The denominator must be non-zero. So take the denominator part and replace d square by minus 9. You'll get 1 minus into minus plus 81 into 9. 9 ones are 9, 9 eights are 72. You'll get 729, which is equals to 1 plus 729 is 730. Non-zero, right? So let's replace d square by minus 9 here. Because by replacing d square by minus 9, we get the denominator non-zero, right? Then we'll get 1 plus 90 by 1 minus 81 into minus 9 into sine 3x, which is equals to 1 plus 90 by 1 plus 81 into 9 is 729 into sine 3x, which is equals to 1 plus 90 by 1 plus 729 is 730 into sine 3x. Again, we can split this as 1 by 730 into 1 plus 90 into sine 3x, which gives 1 into sine 3x is sine 3x plus 9 d sine 3x. We know that d is a differential operator. So we can write this as 1 by 730 into sine 3x plus 9 into d by dx sine 3x. Now we need to find derivative of sine 3x with respect to x equals to 1 by 730 into sine 3x plus 9 into derivative of sine 3x with respect to x is 3 cos 3x, which is equals to 1 by 730 into sine 3x plus 9 3s are 27 cos 3x. Or you can write this as 1 by 730 into sine 3x is 1 by 730 sine 3x plus 1 by 730 into 27 cos 3x can be written as 27 by 730 into cos 3x. Therefore, yp1 equals to 1 by 730 into sine 3x plus 27 by 730 into cos 3x. Now let's find yp2. We have yp2 1 by 2 into 1 by yp2 1 by f of d into 1 constant. So we can write it as constant into 1 by f of d into 1. Since we are having constant, so we can write it as some 1 by f of d into e power 0x form, right? Since e power 0x equals to e power 0 and also we know that e power 0 is 1, so we can replace this 1 by e power 0, then this becomes 1 by 2 into 1 by dq plus 1 into e power 0x, right? We are having this. We have f of d equals to dq plus 1, and this is 1 by f of d into e power ax. For a equals to 0, we need to find f of a. For a equals to 0, just replace d by 0 in f of d, then you'll get 0q plus 1, which is 0 plus 1, 1. Since f of 0 is non-zero, so we can replace d by 0, then we'll get 1 by 0 cube plus 1 into e power 0x is 0, just write e power 0, okay, equals to 1 by 2 into 1 by 0 cube is 0, 0 plus 1 is 1 into e power 0 is 1. So finally you'll get 1 by 2 into 1, which is equals to 1 by 2. So therefore yp2 equals to 1 by 2. One by 2 into 1 by f of d into cos x. So this is of 1 by f of d into cos ax form. Now we need to find d square, which is given by minus a square. Then for a equals to 1, we'll get minus 1 square equals to minus 1. Now let's see what happens if we replace d square by minus 1 in the denominator. The denominator must be non-zero. Take d cube plus 1. You can write d cube as d square into d. Now replace d square by minus 1, you'll get minus 1 into d plus 1, which is equals to minus d plus 1, is equals to 1 minus d, non-zero, right? So the denominator is non-zero by replacing d square by minus 1. So what we'll do, we'll just replace d square by minus 1. Before that, write d cube as d square into d plus 1 into cos x is equals to 1 by 2 into. Now replace d square by minus 1, then we'll get minus 1 into d plus 1 into cos x, which is equals to 1 by 2 into 1 by minus d plus 1 into cos x. Then yp3 becomes 1 by 2 into 1 by d minus d plus 1 can be written as 1 minus d into cos x, right? is equals to 1 by 2 into. See, you are having 1 minus d in the denominator. So if you replace this minus by plus, you will get 1 plus d, right? So now let's multiply and divide 1 plus d to this fraction. Then we'll get 1 by 1 minus d into 1 plus d by 1 plus d into cos x is equals to 1 by 2 into 1 into 1 plus d is 1 plus d by 1 plus d into 1 minus d into cos x. If you notice in the denominator you're having a plus b into a minus b, right? You're having 1 plus d into 1 minus d, which is of a plus b into a minus b form. You can write it as a square minus b square. Then this becomes 1 by 2 into 1 plus d by 1 square minus d square into cos x. Right? Now we are having yp3 equals to 1 by 2 into 1 plus d by 1 square is 1 minus d square into cos x. Again, d square appears in the denominator. So what we have to do, we have to see what happens if d square is replaced by minus 1. Okay. So the denominator must be non-zero, right? Replace d square by minus 1. Then you'll get 1 minus of minus 1, which is 1 minus into minus plus 1 is 2. Non-zero. So the denominator becomes non-zero by replacing d square by minus 1. So let's replace d square by minus 1. Then this becomes 1 by 2 into 1 plus d by 1 minus of minus 1 into cos x, which is equals to 1 by 2 into 1 plus d by 1 minus into minus plus 1 into cos x. Right? Which is equals to 1 by 2 into 1 plus d by 1 plus 1, 2 into cos x. Now, you can write this as 1 by 2 into, you can write 1 by d by 2 as 1 by 2 into 1 plus d. Okay, we'll write 1 plus d by 2 as 1 by 2 into 1 plus d into cos x, which is equals to 1 by 2 2s are 4 into 1 into cos x is cos x plus d cos x. We know that d is a differential operator. Now this becomes 1 by 4 into cos x plus replace differential operator d by dx. Now here we need to find derivative of cos x with respect to x, equals to 1 by 4 into cos x plus derivative of cos x with respect to x is minus sin x, equals to 1 by 4 into cos x minus sin x. Therefore, yp3 equals to 1 by 4 into cos x minus sin x. Now let's find yp4. yp4 is 1 by f of t into cos2x is of 1 by f of t into cos x form for a equals to 2. Right? We can write d cube as d square into d. Then the denominator becomes d square into d plus 1 into this cos2x. Now let's find d square, which is given by minus a square. Then for a equals to 2, you'll get minus 2 square equals to minus 4. Now let's see what happens if we replace the denominator by minus 4. The denominator must be non-zero by replacing d square. So replace d square by minus 4, you'll get minus 4 into d plus 1 equals to minus 4d plus 1. You can also write it as 1 minus 4d, which is non-zero. Since the denominator is non-zero by replacing d square by minus 4, so we can replace d square by minus 2 square equals to minus 4. Then this becomes 1 by minus 4 into d plus 1 into cos 2x, which becomes 1 by minus 4 into d is minus 4d plus 1 into cos 2x, or 1 by 1 minus 4d into cos 2x. See, in the denominator you are having 1 minus 4d. If you replace this minus by plus, you will get 1 plus 4d, right? So let's multiply and divide 1 plus 4d to this fraction. Okay, then you will get 1 by 1 minus 4d into 1 plus 4d by 1 plus 4d into cos 2x. Now we can write this as 1 into 1 plus 4d is 1 plus 4d by 1 minus 4d into 1 plus 4d. You can write it as 1 plus 4d into 1 minus 4d into cos 2x. In the denominator you are having 1 plus 4d into 1 minus 4d. This is of a plus b into a minus b. So you can write it in a square minus b square form, equals to 1 plus 4d by 1 square minus 4d whole square into cos 2x, which is equals to 1 plus 4d by 1 square is 1 minus 4 square is 16 into d square into cos 2x. Again, d square appears in the denominator. So what we have to do, we have to check what happens if we replace d square by minus 4. Always remember that the denominator must be non-zero. If we get denominator 0, we'll get some numerator by 0 into cos 2x. You know that if the denominator becomes 0 after replacing d square by minus 4, the total term becomes undefined, since 1 by 4d by 0 becomes undefined. Right? The denominator must be non-zero. Now, take denominator and see what happens if we replace d square by minus 4. 1 minus into minus plus 64, 64. 1 plus 64 is 65, which is non-zero. Since we got non-zero by replacing d square by minus 4 in the denominator, so let's replace d square here. Replace d square by minus 4, then this becomes 1 plus 4d by 1 minus 16 into minus 4 into cos 2x, which is equals to 1 plus 4d by 1 plus 64 cos 2x you get 1 plus 4d by 64 plus 1 is 65 into cos 2x. Again, you can write this as 1 by 65 into 1 plus 4d into cos 2x this becomes 1 by 65 into 1 into cos 2x is cos 2x plus 4d cos 2x. We know that d is a differential operator. Then replace d by dx into cos 2x. Now we need to find derivative of cos 2x with respect to x here. We'll get 1 by 65 into cos 2x plus 4 into derivative of cos 2x with respect to x is minus 2 sin 2x. This becomes 1 by 65 into cos 2x plus into minus minus 2 4s are 8 sin 2x. Therefore, yp4 equals to 1 by 65 into cos 2x minus 8 sin 2x. Now coming to yp. Now yp becomes, replace the result obtained by yp1, yp2, yp3 and yp4. Then yp is equals to, result obtained from yp1 is 1 by 730 into sin 3x plus 27 cos 3x minus result obtained from yp2, 1 by 2 minus result obtained from yp3 is minus of 1 by 4 into cos x minus sin x plus result obtained from yp4 is plus 1 by 65 into cos 2x minus 8 sin 2x. Therefore, the general solution is given by y equals to yc plus yp, right? Then y equals to, we have yc, c1 e power minus x plus e power x by 2 into c2 cos x root 3 by 2 plus c3 sin x root 3 by 2 plus yp 1 by 730 into sin 3x plus 27 cos 3x minus 1 by 2 minus 1 by 4 into cos x minus sin x plus 1 by 65 into cos 2x minus 8 sin 2x. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.